Alright, here we go. Okay, so this is another layer of your differentiation. And you know, just like the chain rule, we're only going to use it when we have to. Because we don't have to, we're not going to use it because then it would be wrong to use it, which is so stupid. But anyway. Okay, this is implicit differentiation. Okay, and it's used when we don't have a function that is defined by y equals. This is what we're used to for functions right here. Y equals no y's on this side. Okay, now this is an implicit function where if we solve it for y, we could do that. What happens? What's y? Plus or minus, yes, and that's important. That's really two functions. So it's not even really a function, okay? Because what is this graph? You know? Yes, it is. Good job, Sarah. A circle with radical 7 as your radius. Okay, that's not a function, but that's what they're going to call it. They're still going to call it a function. But that's an implicit function where if you would solve it for y, even sometimes you can't even do that because there's too much involved. It's not a function anymore, so there's no point in doing that. You could find two derivatives. No. So this is the process. And we'll take an example because sometimes, just like anything, you don't have to do every step. Okay? But this is only if you have an implicit function. You're going to differentiate both sides with respect to x. Okay? Collect the terms with dy dx. And this is the one time we pretty much use dy dx instead of y prime. Okay? You factor it out and you solve. So let's try an example, and then we'll look at the reasons here. All right, now again, the y squared equals x is your example, and if you solve that for y, you get two different functions. You're not going to make a derivative that's too big. It is for this, okay? So here's what we're going to do. We're going to differentiate. So I'm going to do this, just to say that that's what I'm doing. That's step one. Differentiate both sides, okay, with respect to x. That's key there. X is our independent variable, like always. All right, now, of course, this side is easy. What's the derivative of x? 1. Okay? Now, y squared is a chain rule. Okay? So, derivative of y squared, where u, and y squared is really u squared, where u is y. I know it's weird, just stick with me for a minute, because we can say, well, really, you're going to do this. Okay, what's the derivative of u squared? 2u, and the derivative of y with respect to x is the derivative of y with respect to x. Just ask that. What's the derivative of y with respect to x? Okay. Now, that put our y back in for u, and this is what we have. So that's right here. Okay, now that's kind of confusing. I get that. Okay? But here's what you're going to do. You're going to find your derivative like you would have typically used it as if this was x. So 2y. And then you're going to attach the dy dx, as in multiply it by, because you know it's a chain rule. But you don't really have to do the chain rule if you don't want to, because I know it's very confusing. Does that make sense? So every time you differentiate a y, you're going to just attach that dy dx to the and then do it regularly. Okay, so that's step 1. Step 2 says get all the dy's, dx's. There's only one, so it's already done. Oops. Okay, then it says also factor, but basically we're going to solve for dy dx. Well, in this case, because if you look, factor out it's really already factored and then solved. So we're really skipping, in this case, 2 and 3 and solving for dy dx. Okay? So how do I get rid of 2y that's multiplied? I divide it. So dy dx, which is the derivative of y with respect to x, is 1 over 2y. You could do, if you wanted to, but there's not really any sense to do that. But you can write it 1 over 1/2 times y to the minus 1 if you were going to take it further. Okay? The dy dx is really what we use for implicit differentiation. Any questions? Yeah, more examples, but okay. All right, let's try 2. Find the slope of the circle, which remember is what? Derivative. Okay. X squared plus y squared equals 25 at the point 3, 4. 3, negative 4. All right, so I have a graph here. I put it in there as that 3, negative 4 is right there. Now your graph, I put, I solved it for y just to get a circle going here. There's a gap here that really shouldn't be here. It's just a graphical issue. Okay? So, we're going to, first step is what? No, differentiate. Okay, we can't solve for y, because if we do, we have 2 different things. So there's no point in doing that, because we can't say, well, the derivative is this or this. Okay? All right, so we're differentiating. What's the derivative of x squared? Lindsay. And the derivative of y squared, we just did it from the other side. Sarah? Good job. And the derivative of 25, Sydney? Good job. Okay. Now, dy dx, basically, there's only one, so our goal is to get it by itself. So what should we do first? Okay. Okay. Good job. Nice. 2's gone. Dy dx equals negative x over y. Just leave it alone. It's totally fine. What? Oh, yeah, sorry, yeah. Sorry, I didn't know. All right. X equals, we have more than x on implicit, we have a 3 and we have a negative 4. But you're usually going to have that if you have an implicit function, you're usually going to have a x and a y to solve. Okay, so what's that? Negative 3 over negative 4, which is 3/4. Okay? Now, that's really what? What does that 3/4 signify on this circle? That's right. So if this is your slope, I'm sorry, that's your tangent line. The slope of that tangent line is 3/4. Okay, good job. Okay, so we could also find the equation of it, right? Y minus plus 4 equals, okay, and then you can plug it in and, okay, good. So that's simple. You just do it normally, then attach your dy dx. All right, let's get a little bit more complicated. What does this mean, this symbol? The second derivative. Okay, so that means take the first derivative and then take the derivative of the derivative. All right, so here we go. All right, so let's find, and you can, if it would help you to, solve a little bit, you can. It doesn't really matter. You could throw your 2x cubed over from the beginning if you wanted to. All right, Abby, what's the derivative of 2x cubed minus 3y squared? 6 squared minus 6 dy. Nice. Okay. Equals, the derivative of 8 is 0. Okay? She did 3y squared like normal if it was an x, and then just multiply by dy dx. That's a chain rule thing. All right, now we're going to get dy dx by itself. So what does that entail, Allie? Creepy?
Negative 6y dy dx equals negative 6x squared, and then you divide by negative 6y, and then the x squared over y.
Okay. All right, so this is your first derivative. Remember, we're looking for the second derivative. So we get to start over. Okay? So, take the derivative of both sides. Okay. Now, this is what we get when we take the derivative of the derivative, which is this. Okay? You get to leave that alone. You don't get to manipulate that. There's nothing to manipulate. Okay, what are we going to do to find x squared over y derivative, Emma? Good job. Okay, I'll start with the bottom. I do that most of the time because sometimes I do forget the bottom too. Okay, give me the top, Allie Rivers. Okay, what's this? All right, it's y prime, which is dy dx. Okay, and that's a 1 dy dx. I know you said the 1. Okay, if you need to spell it out, go for it. Allie did not need to, but this was the derivative of x squared. There's your y minus x squared, leave it alone, times the derivative of y with respect to x. You just say it, it makes sense because that's what it is. The derivative of y with respect to x is dy dx. All right, leave this alone, okay, because that's what you're going to get. Let's see what we can simplify. 2xy minus, what is dy dx? So I'm going to put that in here. X squared over y from here. Okay? All right, now I'm going to simplify. Again, I'm leaving the second derivative alone because that's what I want. Now, to simplify, I technically have a complex fraction, don't I? So what's the quickest way to simplify this? To get rid of that extra denominator. Good. Multiply by y over y. Okay? So that would be y times 2xy. 2xy squared minus y times this. Y cancels, and that's x to the fourth. Okay. And y squared times y is, there's your second derivative. You could, would it do you any good to do that? Okay. Yes, if that's your inclination, go for it. If I look and say, okay, that won't do me any good as far as canceling, then I'm just going to leave it alone. Okay? Is that good? Any questions on that? You're not going to leave dy dx in your problem when you're doing the second derivative. You're going to replace it with what it's equal to. And that's where it gets messy. Okay, that was not even very messy. All right, let's try another one. X squared minus xy plus y squared. Oops. You want to try it first? See what we got here. Okay. 2x minus, now I'm going to use the product rule, derivative of x times y plus x times the derivative of y with respect to x. If you want to do y prime at that moment, because that's what you're used to on the product rule, just switch it back at some point to dy dx. Equals, oops, nope, plus 2y dy dx. equals 0. So far, so good?
Yeah.
All right. Subtraction, I'm going to go ahead and do that now. Okay, now here's the first instance that we have to get our dy dx's together. So I'm going to leave these two on the side. I'm going to move these guys over. So negative x, and you can, you know, good algebra students, you can combine some of these steps. I'm just taking it slow this first time around here. This 2x goes over as a negative. This y is a plus y. Okay, so far so good? All right, now I'm going to have to factor out the dy dx. We did that a lot pre-cal when we were doing the log equations where there's something weird in common, but that's your greatest common factor, so that's negative x plus 2y. I saw that, negative 2x plus y over here. And then we're going to divide by negative x plus 2y. Negative x plus 2y is our answer right there. Just rewrite it. Negative 2x plus y over negative x plus y. I know I saw that.
2y.
Where's the, oh yeah, thank you. I know I saw that. You got it. Do I have to leave the negatives in there? What do you think?
Yes. Well,
Right. Because you remember it's the negative. If I don't like the front being negative, then that would be this. And this, which depending on which direction you went with dy dx, you could have gotten that. That's the same thing. But no, these do not cancel out each other. It's just like not a common factor. A factor has to be on the top. So basically you're doing this. And then you're back. And then you're canceling the common factor. Okay. Good question. Any other questions? So where'd y'all go wrong? There seem to be a lot of different answers out there. Oh, okay. All right. You remember to distribute. That's that whole thing of you're remembering to distribute instead of doing your parentheses and you forget something else. All right. Okay, so these are the problems that you could finish for homework. Let's we just did this problem, right? Part A, did we not just do x squared minus xy plus y squared equals 9? Okay, so A is done for you. dy dx equals, what is it again? Negative x plus y over
negative 2x plus y over negative x plus 2.
Okay. Oh wow. Okay. Negative 2x plus y over negative x plus 2y. Okay. All right. Find the coordinate for the points on the curve where the tangents are vertical. All right. Okay. What does that mean? Tangents are vertical. What? That kind of a what's happening as far as the slope goes? Vertical tangents means what? Slope. What? Doesn't exist. Nice, Emma. The denominator of that fraction would equal 0. Okay? So part, let me move this down here. We can do this first one all together. All right, part B. Negative x plus 2y equals 0. Okay? Find the coordinates of the points, maybe more than one, on the curve where the tangents are vertical. Okay, so what do we know here? Negative x plus 2y equals 0. What do we know? 2y equals negative x. Y equals negative 1/2 x. Oh, good. Thank you. Okay. Now, that's not a vertical line. Okay, but remember what this means is where y equals 1/2 x is what those coordinates are where the tangents would be, the slopes of the tangent lines would not exist. Okay, so how do we get some coordinates out of that? Sure. Okay, so you got an x and a y. You need another relationship to get the x and the y to work out, right? Do we have another x and y relationship?
Well, we know that the radius is going to be, no,
It is a circle, actually. Yeah.
so then the radius would be 3, so we know that.
Not really, because this isn't solved in that form yet. But that's the other equation that we need to look at. You have two variables, you need two equations. Okay. How do you get those two equations together to give us, there you go, y equals 1/2 x. So I'm going to do all the y's. I'm going to put in a 1/2 x. Okay, now we're down to x's, so we can solve for x, right? So what's this? X squared minus, what's all that? 1/2 x squared, good. What's that? 1/4 x squared. All right. So that's 1 minus 1/2, that's 1/2, plus 1/4 is how many x squareds? 3/4, nice. Yes. Did you love it? All right, 3/4 x squared. So multiply by 4/3. So x squared equals 12. X equals plus or minus radical 12. If you want to simplify that, that's fine. You don't have to. Okay, so far I have this ordered pair and half of an ordered pair. Whoa. Okay, I'm looking for coordinates of the point, so I need a y too, right? This is a true AP problem. It is, yes. Okay, so where am I going to plug that back in? Where? Yeah, that would be the best place. That would be the simplest. You could plug it in here, because that's where it came from, here or here. But it makes sense to put them in here. 1/2 times plus or minus 2 radical 3. I can do those both in one shot there. So y equals plus or minus radical 3, right? Which one goes with the plus one? The plus one and the minus one. That's, oopsie, that's your answer for B right here. Okay? So it was I don't know that you've ever done something like that before, but you know, when you have two variables, you gotta have two relationships between those two variables. That's your, you know, algebra 1 elimination substitution business. All right. And part C, we'll finish it up here. Keep scooting this down. Part C, at the point 0, 3, find the rate of change in the slope of the curve with respect to x. What the heck are they asking us to do? Rate of change in the slope. That's right. Rate of change. The slope is the derivative. The rate of change of the slope would be the second derivative. The double. Or double. The double. D at 0, negative 3? 3. Okay. All right. So that's what we're asking us to find. All right. Remember dy dx was what? What is it again? Okay. So this is pretty intense, right? Because we're going to have to start with what?
You didn't give us one.
Oh, I didn't give you nearly enough room because I thought you were going to do it by yourself on a piece of paper, I suppose. Wow. I wasn't trying to be sassy. All right. I was thinking, what am I going to do? Mushroom. That's right. All right. So this is the, we're going to leave this alone. Quotient rule. The bottom is squared. All right. Okay, Hannah, give me the top.
I have -2, or in parentheses, -2 plus dy dx
Nice.
times, another parentheses, -x plus 2y
Okay, I'm glad you're being very picky about your parentheses. This is important.
minus another parentheses, -2x plus y, and parentheses, another parentheses, -1 plus 2 dy dx.
Nice. Perfect. All right. Whew.
Well, so, in yours.
Pen is, I'm getting further down here.
You can't give us.
I know. I should literally write wrestling cage. Sorry. Okay. Now look carefully. Is there a -x plus 2y that we could simplify out of the bottom, this piece and this piece, because it's like a common factor? There's one here, but I don't think this is going to be one. So we can't do that. So we're going to have to.
I mean, unless you.
All right. Okay, so we know dy dx. First of all, we are going to plug in 0, 3 for x and y. So I see no point in spending a bunch of time simplifying. Okay, so I'm going to right now put in my dy dx. Okay, my dy dx, remember, is right here. So I'm going to put that in first before I distribute, because I'm not really going to spend time distributing. I'm just going to be real careful when plugging in. Okay.
I know you're going to go ahead and plug in your.
I am, but I'm going to do it. Yes. You want to do it now? I'll do it in a minute. With my tiny little eraser. I do like to use it, you know. Tiny little eraser. Okay. -2x plus y over -x plus y.
I think you're to know.
Okay. I got the dy dx put in there correctly, right? Oh, where?
The bottom is 2y.
Thank you. All right, now we're going to take another colored pen and put in our x is 0, our y is 3. You already did that. You're good. Okay, here we go. X is 0.
You have a bite to show them. I just like, oh no.
We could have done that once and be done with it over here too. Looking back. Okay, our y is 3. What the heck? Oh, shoot. Oh. Away. Lord Christ. I'm trying to undo. No! Oh, no. I was trying trying to take the y out too soon there.
And the error is so simple.
Yeah, it usually is. Which is a good thing, because then it's, yeah. It's fresh. And y is 3. So, looking back,
Was it worth it? No.
no, make sure I got all my y's good.
Okay.
Okay. Got my y. Looking back, I probably should have plugged this in and got a number and plugged that in for this mess. Yeah, that would have been smarter. Okay. So what is that number? Your x is 0. And your y is 2 or 3. So that's 3 over 6, that's 1/2. So every time you see this, it's 1/2, right?
Yeah, I was gonna say, that's right, yeah.
So that's 1/2. 1/2. Okay. Here we go. This is 6 squared, 36 on the bottom.
Parts of it?
Negative 2 plus 1/2 times 6 minus 3 times negative 1 plus 2 times 1/2. Okay. All right. This is 1, this is 0. So that's done then, right? This whole piece cancels itself out because it's 0? Okay, watch your parentheses when you're substituting. And yeah, because see, this is 1/2. This is 2. 2 times 1/2 is 1. 1 plus negative 1 is 0. 0 times anything is 0. So that mess is 0. Okay. Negative 2 plus 1/2. I'm just going to distribute. Let's negative 12 plus 3. So what's that? Negative 9/36 or negative 1/4? Is that what y'all got? Yes?
No.